Hi everybody, welcome to this unusual isolated WF repair video. I didn't think I would make a video out of this repair attempt from the beginning, but it's turning out quite interesting. This is an HP-8640B signal generator, and I've already opened it and installed a razor on the card I believe is faulty. The HP-8640B is an old but very nice signal generator, going from 500 kHz to 500 MHz in its base configuration, capable of AM and FM modulation. I actually have two of them, and the one I've just opened actually has the optional internal frequency doubler, so its range is in reality extended to a bit more than 1 GHz. This instrument also has the variable frequency audio oscillator option, which is the board I raised before. This is known as option 001 for this instrument. If we look at the audio output and turn on the internal modulator, we don't see a nice sine wave, and the frequency is also off. It should be 400 Hz, not 261. Now, in reality, in this instrument, the internal modulator failed a few years ago, but I didn't bother trying to fix it, because I could still use an external audio source for AM or FM modulation when needed. However, recently it developed another fault, and the FM modulation wouldn't work at all anymore. It turned out I had to glue back the contacts on the rotary switch you see in this picture. These contacts falling off these switches is one of the major issues of this instrument. Anyway, since I had to open it, I thought I'd try also to fix the internal oscillator board. An instrument like this would be almost impossible to fix if we didn't have the full service manual available. Actually, the 8640B has so many different revisions that we need a few different service manuals to cover most of them. I provide some useful links in this video description. This poor scan is the schematic that more or less apply to my instrument revision. We are looking at the option 001 variable frequency oscillator. I'll be looking first at the signal at TP4 and try to adjust the oscillator amplitude to check if the distorted waveform is a result of a fault in the oscillator itself or is generated by a fault in one of the following amplifier stages. The waveform output from the oscillator is indeed bad, and it doesn't even react to the amplitude trimmer in any way. What we have observed already can restrict the fault area a lot. Since the oscillator amplitude cannot be varied, the fault must be either an open trimmer or a failed Tier 1 assembly, whatever that is. So let's measure the Tier 1 assembly. We have some resistance between C and A pins, but it is open circuit between B and A. That's the problem. The parts list on the service manual is not helping much. All it says is an HP part number 5080-1718 and simply thermistor as description. However, putting the HP part number on Google revealed that someone else already figured out what's inside, and it's a combination of 3 small incandescent lamps. I've copied the description I found, plus some other data that I could measure from my partially failed unit and a similar lamp I had in my spare parts. By the way, using incandescent lamps to make a low distortion oscillator is a very common thing in HP instruments since the beginning of the company. Have a look at this interesting Wikipedia page if you are curious. So I've desoldered the thermistor assembly. It seems that the can is just filled with some silicone rubber or similar, so I think I can easily remove most of it. However, since I don't want to damage the good lamps inside, I ended up removing part of the plastic envelope to slide out the potted part. Then, after slowly removing most of the silicone rubber, I found the interrupted lamp, and it's broken. And no, I didn't break it. I've not even found other glass fragments embedded into the silicone. So this is really weird. How can a lamp break like this inside a silicone potted assembly and all the glass fragments disappear? By the way, the other two lamps are intact and I've just removed enough rubber to make room for the replacement lamp. I'll leave them alone for the moment. Here is my other 8640B generator. I was keeping it as a backup instrument because it has less optional features with respect to the other one. I thought I could borrow the thermistor assembly from this one while studying a replacement for the bad one. Notice here this bent connector and case. This instrument had a very turbulent past life, it seems. Here is a better view of the warped case and connector. However, let's check the internal audio generator. And it shows the same distorted waveform. And also the frequency is off. It should be 1 kHz. Since it seems that this other instrument developed the same fault, I decided to start a thread on a group dedicated to HP instruments. And the thread got very interesting too. Dave Wise and others suggested that one lamp must have its envelope broken by design to work properly in that oscillator circuit. In a normal small incandescent lamp, the tungsten filament lives in a bulb where air has been removed. The filament can only transfer its thermal energy by radiating it away if we ignore the small thermal conduction that can happen through the filament support wires. If you are curious, by the way, look for the link of this document in this video description. So the two unbroken lamps in series will then self-heat when a current passes through them and increase their internal resistance, and this will counteract the flow of the current. Eventually, this process will stabilize the oscillator voltage and minimize the output distortion. However, the actual filament resistance also depends from the environment temperature other than the oscillator running current, so the designers added a third lamp, but this one with its envelope broken. This broken lamp will experience a very low self-heating action, because now the filament can get rid of thermal energy by conducting it away to the surrounding material. So the stirred filament resistance will only respond to the environment temperature changes, and by making a voltage divider with the bottom lamps, it will compensate the unwanted variation due to the environment temperature. So I've ordered a few 28V and 40mA lamps. I'm confident enough that most small lamps with similar ratings will have similar resistance. These 28V lamps can have two filament support wires, as the original one I found inside the thermistor assembly. Let me demonstrate the self-heating effect. Whenever I lower the resistance range, the meter test current increases. Eventually, the test current gets high enough and the lamp resistance begins to increase. However, these lamps are a bit too large to fit easily into the original assembly. So I've got smaller ones, always rated for 40mA at 28V. And indeed, also these ones have a resistance between 66 and 70 ohms at around 22 degrees Celsius. I thought a bit how to install the replacement lamp and feel again the whole assembly. So first of all, I'll solder the new lamp to the pins. Here is the other pin soldered. The lamp will fit between the other ones. Now it's time to break the glass envelope. I thought I'd clamp the lamp in a vise, then slowly close it until the glass snaps open. Be sure to support the lamp by one of the pins or it will fly away or drop. And guess how I know this? So now the broken lamp can be positioned between the other two. Of course, I made sure the filament is intact by measuring its resistance. I've installed the cardboard pin spacer that was recovered intact after removing the original filling material. Then I tried to fill everything with 2 components epoxy. However, the epoxy remained too fluid for too much time and leaked away from the broken plastic envelope. My attempts to construct a cardboard envelope also failed miserably. At the end of this big mess, the lamp filament was obviously enough abused and it didn't have any continuity anymore. Clearly, I need a better plan. Since it is usually pointless to attempt a failed plan twice, I changed almost every step. First of all, I've broken the glass envelope of a new lamp. Then embedded the broken lamp into melted glue, and I waited for this glue to solidify completely. In this way, there is no risk to damage the filament, and I could solder the lamp in its final position. Then again I placed all the lamps into the old broken plastic case, and I'm going to fill it with hot glue, which will solidify quickly as soon as it fills most of the gaps. Here we are. Yes, the filament is still intact. At this point, the thermistor assembly can be soldered back on the audio oscillator PCB. For a quick test, I've just installed the card back on the razor. Modulation is on. And yes, we have a nice sine wave now. Even the frequency is more or less correct. Now the final answer will come from the alignment procedure. If it can be completed exactly as indicated in the service manual, it means the replacement works as well as the original component. Unfortunately, I haven't found the exact procedure for my instrument revision, so I need to make an educated guess, for example on the oscillator voltage output. There would be definitely the need for more revisions of this instrument's service manual, scanned and shared. However, after about 1 hour following the procedures, it seems that all frequencies and voltages are in the indicated ranges. At this point, the first instrument has been closed again and put back on the bench, so I have now opened my second 8640B to repair its audio oscillator board. To remove the option 001 PCB, we need first to remove the instrument's top cover and remove one screw holding that PCB. However, after removing the top cover, I've also noticed this rifa capacitor that's already cracked, and it must be replaced for sure. So I've just used a more reliable film capacitor rated for X2 mains operation and with the same value of the original one. By the way, in this 8640B revision, the band and frequency modulation selector switches are this classic and more reliable version, not the other kind I had to repair in the other instrument. Anyway, back to the oscillator fault. Let's measure the lamps. These are the bottom ones. And yes, this one is open circuit. Now I think I have a problem. Looks like this assembly is filled with a very hard substance. So I tried drilling into the assembly until I found the broken lamp. Then I realized that this hard material could be easily softened with the soldering iron tip and removed easily, but at this point only one of the two series bulbs was still intact. First lesson learned. I then ordered some random 12-volt 40 mA lamps to replace the one that I destroyed while drilling the assembly. At time of video editing, I know that these lamps are not very well suitable for this replacement, so let's see why. When I received the new lamps, I've only checked that indeed they would draw about 40 mA at 12 volts, more or less. However, let's observe the original lamp on the left and the new one on the right. We can see that the filament in the original lamp is only supported at the two ends, but on the replacement I've got, there is an additional support in the middle. This additional support adds a delay to the self-heating effect of the filament, but I've discovered this only when I started the alignment procedures. If you need to substitute the 12-volt lamps in a similar assembly, make sure you get the ones with no additional filament support. The effect of the filament support slowing down the self-heating action can be seen at oscillator turn on. As you can see, it takes a good fraction of a second to stabilize the waveform amplitude. Also, I tried to reuse the only lamp that survived the assembly demolition process, but its pins were too abused and fell off. So, together with the new lamp that needs its envelope broken, I also had to use two new lamps for the other half of the thermistor circuit, and then I made a small cardboard support to hold the pins in the correct position. The assembly was then filled with hot glue, as I did for the previous one, and soldered back in its place. The audio oscillator PCB is back into the instrument. Let's quickly check the output. We have a nice sine wave. The frequency is almost correct too.